Hello everyone, so for today I'm going to show you qualitative tests that are used to identify some common functional groups. Functional groups are a group of atoms in an organic compound that is responsible for its specific chemical behavior. Functional group is one of the most simplifying concepts in organic chemistry as it allows us to group diverse organic compounds into families. There's plenty of functional groups in organic chemistry, but for this video, we will be only dealing with the most common ones. Let us begin with a qualitative test used to determine the presence of unsaturated carbon-to-carbon bond in a hydrocarbon. Unsaturated bonds refer to carbon-to-carbon multiple bonds such as the ones in alkenes and alkynes. Otherwise, they are known as saturated like in alkanes. The specific test that we will be using is the von Bayer's test for unsaturation. The reagent used for these tests is the purple potassium permanganate solution, which is reduced to brown manganese dioxide in the presence of a carbon-to-carbon double bond or carbon-to-carbon triple bond. The hydrocarbon samples used in this experiment is cyclohexane, and benzene. The test is very simple and is done by adding 1 ml of potassium permanganate solution into test tubes containing 1 ml of each of the hydrocarbons. Shake each test tube after the addition of the permanganate solution. The formation of a brown coloration is a positive test. This is indicative of the presence of unsaturated bond. To repeat, the reason for this is that the unsaturated bonds is able to reduce the purple permanganate to brown manganese dioxide. The next set of qualitative tests is used to determine the presence of alcoholic and phenolic groups. Alcohols are organic compounds that contain hydroxyl groups attached to a saturated carbon, such as in ethanol, while a phenol has its hydroxyl group attached to a benzene ring. The first test I'm gonna show you is a Bordwell-Wellman test, which is used to determine what type of alcohol is oxidizable. The oxidizing agent for these tests is potassium dichromate solution with concentrated sulfuric acid. Recall that alcohols can be classified as primary, secondary, or tertiary based on the number of carbons directly attached to the carbon bonded to the hydroxyl group. The Bordwell-Wellman test determines which among these alcohols can be oxidized. The representative alcohols used for this experiment is ethanol as primary alcohol, isopropyl alcohol as secondary alcohol, and tert-butyl alcohol as tertiary alcohol. The Bordwell-Wellman test is conducted by adding 1 ml of potassium dichromate solution into each test tubes containing already 1 ml of each of the representative alcohol. The test is also conducted in a 1 ml phenol solution. After which, 5 drops of concentrated sulfuric acid was added to each test tube. The test tubes were then shaken for proper mixing. The appearance of bluish-green or green solution is a positive result. This is because the oxidizable alcohols can reduce the orange dichromate ions into green chromic ions. The result of phenol is brown due to its specific oxidation products. The next test is the Lucas test. This is a differentiating test among primary, secondary, and tertiary alcohols. The reagent used for the test is a mixture of concentrated hydrochloric acid and zinc chloride. This is known as a Lucas reagent. The reagent converts the alcohols into alkyl chlorides. This is evidenced by the formation of a cloudy layer after the reaction. The speed of the reaction is what differentiates the different types of alcohol, wherein the tertiary alcohol reacts the fastest and the primary alcohol reacts the slowest. The Lucas test is conducted by adding 1 ml of the Lucas reagent into the test tubes containing already 1 ml of each of the representative alcohol and phenol. Notice how the tert-butyl alcohol reacts immediately upon the addition of the Lucas reagent, as evidenced by the formation of a cloudy layer. After standing the test tubes for 5 minutes, isopropyl alcohol showed the same result, while ethanol and phenol showed no appreciable reaction. The third and the last test is a specific test for the phenolic groups, the ferric chloride test. As the name of the test already implied, this utilizes ferric chloride solution as its reagent. This test is based on the fact that the phenolic groups can form a purple-colored complex with the ferric ions, which cannot be seen in any other compounds containing the hydroxyl group. The test is very simple and is just conducted by adding 1 drop of ferric chloride into test tubes containing already the representative alcohols and phenols. The formation of purple coloration is a positive result which indicates the presence of phenolic group. As a summary, here are the results of the different tests. This one is for the Bordwell-Wellman test. Next is the result of the Lucas test after standing for 5 minutes. And lastly, the ferric chloride test for the phenolic groups. Now we'll proceed to the qualitative tests used to determine the presence of aldehydes and ketones. Aldehydes and ketones are organic compounds containing both carbonyl groups. If the carbonyl group is found in between a carbon and a hydrogen, then that compound is classified as an aldehyde. This is the case of the compound acetaldehyde. On the other hand, if the carbonyl is present in between 2 carbons, then the compound is classified as a ketone, such as the case of acetone. The first test is the 2,4-DNP test, or also known as the 2,4-dinitrophenylhydrazine test. This is a general test for the presence of carbonyl group, which means to say both aldehyde and ketones will give a positive result. The positive result is the yellow precipitate, which is the dinitrophenylhydrazone product produced by the reaction between the 2,4-DNP and the carbonyl compound. The representative aldehyde used for this experiment is acetaldehyde. The representative ketone is acetone. I also used ethanol in the experiment for comparison of results. 2,4-DNP test is conducted by adding 1 ml of the 2,4-DNP solution into a test tube containing already 1 ml each of acetaldehyde, acetone, and ethanol. Then, the test tubes containing the mixtures were then heated in a boiling water bath for 5 minutes. While heating in the water bath, yellow precipitates were starting to form in some of the test tubes. After heating, the results show that only acetaldehyde and acetone were able to form yellow precipitate, while ethanol did not. The next test is a tolerance test. This is used to differentiate between aldehydes and ketones. The test is based on oxidation reaction. Between aldehydes and ketones, only aldehydes can be oxidized and thus will be the only one to give the positive result. The positive result is the formation of a gray precipitate or a silver mirror, which is due to the conversion of the reagent into silver metal. The test is conducted by adding 1 ml of the tolerance reagent into the test tubes already containing 1 ml of acetaldehyde, acetone, and ethanol respectively. The test tubes were then shaken and heated in a boiling water bath for 2 minutes. After heating the mixtures for 2 minutes, only the aldehyde was able to produce the positive result, which is the gray precipitate. As a summary, here's the result for the 2,4-DNP test. And here's for the tolerance test. The last set of qualitative tests are used to determine the presence of carboxylic acids. Carboxylic acids are organic compound containing the carboxyl group. The carboxyl group is a suprafunctional group which is a combination of a hydroxyl and a carbonyl, such as in the case of acetic acid. This combination of carbonyl and hydroxyl has a characteristic acidic property which gives carboxylic acid the status of being a separate functional group. This acidic property of carboxylic acids makes it easy for us to differentiate it from the rest of the functional groups, as we shall see in the following tests. The first test is a very simple blue litmus paper test. As we already knew, blue litmus paper will turn red upon contact with an acid. Thus, the same reaction is expected for carboxylic acids having acidic properties. The representative carboxylic acid used in the experiment is acetic acid. Ethanol and acetaldehyde were also used for comparison. As mentioned, the test is very simple. Add a drop of ethanol, acetaldehyde, and acetic acid into prepared blue litmus paper in a watch glass. The turning of blue litmus paper to red is an indication that the substance contains an acidic group. Such observation is seen in acetic acid. The final procedure for this experiment will be the sodium bicarbonate test, which utilizes saturated sodium bicarbonate solution. The acidic group of carboxylic acid will react with bicarbonate ions, producing carbon dioxide, and is seen as the formation of the effervescence. This test is conducted by adding 1 ml of saturated sodium bicarbonate solution into each test tubes containing 1 ml of ethanol, acetaldehyde, and acetic acid respectively. The formation of effervescence or bubbling indicates positive result, which shows that carbon dioxide was produced. This result is shown in the reaction between the bicarbonate ions and acetic acid. As summary, here is the result for the blue litmus paper test. And here's for the sodium bicarbonate test. So there you have it, the different qualitative tests for identifying common functional groups. Have a great day!